Okay, we start our lesson now. Good evening, Form 5. This is today is Wednesday, right? Okay, I have to rethink that today is Wednesday or Thursday. Okay, this one is Form 5 Wednesday groups. So nice to meet everyone here again. Okay, so I'm sure everyone here very happy because at least you have a few days of holiday Okay, at least you can enjoy a few days without online class, without tuition, right? Okay, can stay home, can rest. You either celebrate your Chinese New Year or you don't celebrate, so you can rest. Okay, so tonight, tonight our tuition will stop at 9:15 now. I release you 30 minutes earlier. This is the Chinese New Year week. I think everyone very busy, want to do a lot of preparation, right? Okay. So I start lesson by sharing the paper with you now, okay? Our last lesson, I suppose we stop here, I think. Stop somewhere here, correct not? Here, right? The spring, correct not? Spring constant. Have we done spring constant here? Have we done this one? We stop here, is it correct? You don't? We stop here, correct not? You don't? Is it correct? We stop here. We stop here now. Okay, before I continue any further now, I would like to ask a few questions. Okay, first question, listen properly, student. Okay, what are the factors affecting the stiffness of a spring? Meaning that a spring is stiff or soft, right? Is affected by what factor? 1 minute from now, get ready now. When I call your name, so you answer. What are the factors affecting the stiffness of a spring? Okay, there are few factors affecting the stiffness. What are those factors? Okay, 1 more minute from now. Okay, thumbs up. Yeah. So when I call your name, so you answer now. Okay, let's choose Karin. Karin Yong. Karin Yong, are you there? Karina.
Yes, teacher.
Karin, okay, can you tell me what are the factors affecting the stiffness of the spring? Just tell me what
Type of spring material.
Types of material, correct? Next.
Diameter of wire of spring.
Yes, the diameter of the wire of the spring. Okay, third.
Diameter of spring coil.
Yes, the diameter of the coil. Okay, very good. One more.
Spring arrangement.
Spring arrangement. Okay, Karina, which arrangement now produce a very stiff spring? Which types of arrangement is better?
Series.
Series better lah. Karina.
Yeah.
You sure or not?
Series is teacher,
Better
parallel.
Which one?
Parallel.
Parallel one better, right? Parallel means it will produce a very stiff spring. Okay, that's good already, Karin. Okay, thank you very much.
Thank you, teacher.
Yes, thank you. Next one. Now remember your name last time. Every time I have to see the name only can know. Evangeline. Evangeline. Are you there? Evangeline. Lazaro. Evangelina. Are you there now? Can talk or not? Evangeline can talk. I can't hear you lah. Now mai là ngu yêu tông à, yêu tông à, yêu tông, please.
Yes, sir.
Yêu tông, okay. Can you tell me other factors are affecting the stiffness which is not mentioned by Karen just now?
The original length of the spring.
Yes,
and the
original
spring
length. What else?
The spring constant.
The spring constant. Yeah, any more? Original length, spring constant. That's all.
Yes.
The rest all mentioned already. Okay, thank you very much. Okay, Evangeline. Okay lah, Evangeline, can you type? You don't want to talk, never mind, you type like you type three factor affecting the stiffness. Evangeline, can you type now? Or you want to talk also can talk. Evangeline. Okay, come, let's see your answer now. Spring constant. Okay, can you type one more? Eventually, one more spring constant affecting stiffness. Yes, correct. Original length. Okay lah. One more lah. Last. One more is what, Evangeline? Spring constant, original length, diameter of the spring coil. Yes, correct. Good. Okay, thank you. All right, I think the one okay already now, huh? Okay, next one, we look at this. This one we are going to start here, huh? The use of elasticity in everyday life. Okay, we know that actually elasticity is very important, So where we use it in our life. Okay, first one, please highlight in cushion and mattress. Inside the cushion or inside the mattresses. Okay, the cushion, when you sit on it, very comfortable, right? Elastic. Mattress also the same. Why? Because actually, inside the cushion or inside the mattress, you have a lot of spring inside. They put spring inside one, The one become elastic is because of the spring. They put the spring inside, okay? Highlight. The spring in the cushion or mattress undergo many cycles of compression during the use each time, able to return to the original shape. This is due to the elasticity of the spring. So you must have very good quality spring now so that it will last long. Okay, the mattress, the cushion will last long. The spring must be very good quality. Okay, good quality means it can return to the original size every time. Okay, so remember now, first one is in the cushion or mattress. Okay, second one is electric meter. Okay, electric meter here is example like ammeter lah, watt meter lah. You see, you see this is an ammeter. This is a meter, right? So you have a pointer here. When you connect to current, you see the pointer deflect. It will deflect, correct? Not immediately, it will deflect. Okay, so the pointer deflect, you must have something to stop it, Okay, they must have a spring here. There must be a spring to stop the deflection. The pointer deflect, so you must have something to stop it, okay, so that you can read. If nothing to stop it, so the pointer will deflect to the maximum point every time. That doesn't serve the purpose lah. So you need to put a spring here to stop the deflections of the pointer. And also to return the pointer back to zero when you disconnect the current. When you disconnect, the pointer is supposed to go back to zero. So you must have a spring once again to push the pointer go back to zero. So that's the purpose of elasticity in the electric meter. Electric meters such as ammeter, wattmeter, galvanometer have spiral spring. Okay, spiral spring, spiral means like this, the shape, the spring is like that one, spiral shape. Okay, like this. Actually, this is a normal shape of the spring, spiral shape. Okay, so the spring is like that, spiral shape. The spring are used to stop the pointer at a specific point and to return the pointer to zero after measurement have been taken. Important, So the second uses of this elasticity is electric meter. First one is cushion and mattress. Second is electric meter. Okay, third one is weighing apparatus, weighing skill lah. To measure your body weight, the machine you stand on it also they have a spring inside. Okay, they use a spring to detect your weight, weighing apparatus such as spring constant, highlight. A spring is either extended or compressed, and it obeys the Hooke's law, and cause apparatus has a linear scale. Okay, so to measure our weight, measure our mass, so there must be a spring inside. The spring is either be compressed when you stand on it, or the spring is being extended when you pull it, right? Extended or compressed, and it produce a linear scale. Linear means directly proportional. So third one is weighing scale, weighing apparatus. Second one is electric meter. The first one is mattress, cushion, all this, right? Okay, now fourth one is vehicle spring support. Okay, now you see this diagram. This is a tire of the car. From outside, you cannot see the spring, but when you open up here, you can see one. Beside the tire, there's a spring here. Actually, each tire will have one spring, okay? They call it spring. But the spring is being covered in a tube, so you cannot see the spring. You see a tube only. But inside the tube, actually, there's spring, okay? So when a car have 4 tires, means they will have 4 spring. So this spring function is to stop the vibration. Because when the car go over bumpy road, the car will vibrate, isn't it? When the car vibrates, so the spring will vibrate 1 time, 2 times, then stop, absorb the vibration. So the spring help to stabilize the car by absorb the vibration. So very good. A good car now shouldn't vibrate when go through bumpy road. It vibrate 1 time, 2 times, they must stop. You cannot continue. You continue to vibrate, then a lot of people not comfortable when you sit inside. That is a functions of spring in vehicle support system. Normally, we don't call support system, we call suspension. Vehicle suspension system. Suspension to suspend, to stop the vibration. Enable the passenger in a vehicle to be seated in a comfortable position when the vehicle goes on a bumpy road because the spring shock absorber. Okay, the real name is called shock absorber. This is a shock absorber to absorb the shock. Okay, shock absorber, the spring. Okay, so remember now, vehicle spring support. Okay, or sometimes, most of the time, actually, we call it shock absorber to absorb the shock, to stop the vibration. Okay. All right, continue here. The shock absorber are mounted on the wheel of vehicles to absorb the impact and damp. Damp means to stop. Damp, another meaning of stop, okay, to stop the vibration resulting from the movement of on the bumpy road or uneven road. Okay, so remember, you must know the meaning of damp. Damp means to stop the vibration. And number 5. You must remember, later on I will call you to answer my question. Later on is in the sport, okay, in the sport. Elastic strings of tennis racket or badminton racket. You know, right? The badminton racket, the tennis racket, they have the string, right? Okay. Enable them to rebound the ball or shuttle. This is very good, no? In the badminton racket, tennis racket, they use string, right? Elastic string. They use the elasticity to rebound the ball, to rebound the badminton shuttle. Okay. All right. Number 6. This one is number 6. The rope. This one is number 6. Okay. My writing very good. I don't want to write. I type. Okay. Sorry. One moment. Okay, over here. This one is number 6. Please write number 6. Okay. The rope used by the rock climber have elastic property. You know that the people go to climb the rock, right? They use a special types of rope to tie up the body to hang there for safety. Huh? So this rope has elasticity one, you know. The rope used by the rock climber has elastic property that can save life during climbing accident. The rope are made of continuously drawn nylon, to use nylon fiber, and a protective textile covering. Okay, this reduces the stopping force acting on the falling climber. Okay, so because the string is elastic. Elastic means when the climber is falling, right? When he's falling, but the rope is holding his body. So you wouldn't stop the falling climber straight away. Then you kill the person, you know. If it's elastic, the bumpy jump, you know, right? You see the rope got elastic one. Okay, so people would get injured now when they're falling. Okay, so number 6 rope used by rock climber. And the next one, the last one, number 7 is here. Okay, the ball band or elastic twin of ball is stressed to store elastic potential energy used to propel the arrow. Okay, shooting arrow, right? So you pull the ball, let go, so the arrow shoot out. So that use elasticity to produce a potential energy, elastic potential energy. Ball bands or elastic twins of ball is stressed to store elastic potential energy used to propel the arrow. You want the arrow to go very far, very fast. So your elasticity must be more. Okay, so there are 7 examples of application of elasticity. Okay, 2 minutes from now, memorize it. Okay, when I call your name, you tell me answer. Please memorize it. All the 7 examples of uses of elasticity. Okay, start from now. Memorize. Okay, 1 more minute. Okay, time's up. Time's up. All right, first person I want to call Mr. Bernard. Bernard, how can you come out, please, Bernard?
Yes, sir.
Bernarda,
Yeah.
can you tell me four uses of elasticity? Give me 4 examples, can or not? First one is what?
Cushion or mattress.
Cushion or mattresses. First one, yes, very good. Second one,
String balance.
used in the weighing skill lah, weighing apparatus lah, like spring balance. Okay, third,
Electric meter.
in the electric meter to stop the pointer or to push the meter back to 0. One more, Bernard.
The spring shock absorbers.
The one used at where? The shock absorber used at where?
Vehicles like car.
Vehicle lah, used in a vehicle lah. Okay, thank you, Bernard. Very good. Okay, next one. Next one, I want to call. I have to open up the name list. Hui San, Tan Hui San, right? Tan Hui San.
The elastic string
Elastic string used at where?
in the tennis or badminton racket.
Yes, very good. One more.
Rope used by the rock climbers.
Yes, the rope used by the rock climber. And one more.
A bow.
A bow. The bow will produce what energy when you stretch it?
Elastic potential energy.
Elastic potential energy, which used to propel the arrow lah. Okay, thank you, Hui San. Thank you. Okay, I think okay lah. This one okay, not difficult lah. So we move on now. The next one is you have to do calculation already now. Okay, first we see the spring system. There are 2 spring systems here. One is series, one is parallel. Okay. This one actually is repetition. Last lesson I informed you a little bit already. Now it's just repeat now. There are 2 types of arrangement. First one, series. Series means one continue by one. Like this one, you put 120 Newton, no sharing one. This spring support 120. This spring also support the same 120. So this doesn't help anything. When you put 2 spring in series to support 120, right? No, you don't have anything because each spring still supports the same 120, 120. So no good. The second arrangement is parallel arrangement. You see, this one got sharing. You put 120 Newton here, right? This one will take 60. This one you only support 60. Means share out already lah. That's why parallel arrangement is better, a better arrangement because it will make the spring stronger, stiffer. Okay, This one very simple. And now we see the example, the calculation. The original length of spring is 5 cm. The spring original length is 5. With a load of mass 20 gram, when you put 20 gram, the length of the spring extended to 7. From 5 cm is extended to 7 when you hang it with 20 gram. Determine the extension of spring when a load 40 gram. P, the length of spring which a load 60 gram. C, the loads required to extend the spring to 20 meters. Okay, come, we see one by one first. First one. Okay, first one, the information given is like this. The spring original is 5 cm. When you put 20 gram, it becomes 7. 5 plus 2 means extended 2 cm. From 5 becomes 7. So that's why you take 20 gram produce 2 cm of extension. You write here. 20 gram produces 2 cm of extension. This is a mass. This is the extension. 5 to 7 extended 2 cm. Okay, now they ask 40 grams. So you put 40 grams. Common sense only. 20 gram can produce 2 cm. Then 40 gram must produce 4 cm. So the extension is 4. So for first answer, the extension is 4 cm. When you put 40 gram, definitely will extend by 4 cm. Okay? Because 20 gram is 2. 40 gram must be double. So 2 times 2 become 4. Okay, huh? Okay, now P, the length of the spring with the load 60. How to do? Okay, now you see here. Huh? Still use our old information. 20 gram will get 2 cm extension. Now 60 gram will get 6 lah. 3 times triple. So 2 times 3 is 6. So common sense only, no? 20 gram extend 2. 60 gram will extend 6. But the question asks the length of the spring. So the length of the spring must be 5 plus 6. Whole thing lah. So it's 11 cm. The original length is 5. Extended 6. So add up become 11 lah. Okay. And the last question. The load required to extend the spring to 20 cm. So how to do? Extend it to 20 cm. Okay, our method is like this. Okay, you see carefully. Now, first thing, you must find the extension. You say extended to 20 means extension is only 15. 20 minus the original length 5, so you get 15 cm. So the extension actually is 15, not 20. Then you start from using the same information. 20 gram produce 2 cm extension. Now, how many gram you put Y can produce 15 cm? 20 gram give 2 cm extension. How many gram you put Y give 15 cm extension? And this one very hard for you to calculate in your heart. So you cross multiply. Cross multiply means you take like this. Y times 2 equal 15 times 20. So cross multiply lah. Y times 2 equal 15 times 20. So Y is 150 gram. Okay. Bring the 2 over to dy. So 150 lah. Yeah. Okay, please copy down the whole answer. Read it through again to understand everything. Okay. 1 minute. Okay, come on. You have to understand it first. Okay, all right, now we move to the next one. Okay, I hope everyone understands this already. Now, example number 2. Okay, read the question. Spring A, now got 2 different spring, but spring A extend 2 cm when hung with 10 gram. Now you put here. Spring A, you put 10 cm, you put 10 gram, you will extend 2 cm. Spring B extend 4 cm when hung with 10 gram. B, spring B, you put 10 gram, you will extend 4. So they are different, A, put 10 gram, extend 2. Spring P, you put 10 gram and stand 4. Okay, it's different. There are two different types of spring. Now, question. Find the total stretch of each of the spring system shown in the figure. Okay, we go one by one. For this, both are spring A, this one spring B. Different one, Spring A, spring B. Okay, we answer one by one. First one, if you put them in series, means you put 20 gram. Spring B, this one support 20. Spring A also support 20. No sharing. Okay, so this one will support 20, support 20. So what happened next? So you see the answer. For spring A, right? 10 gram is 2 cm. Now 20 gram, here put 20 gram. 20 gram must be 4 cm, correct not? 10 gram is 2. 20 gram must be 4. So meaning that this one become 4, extended by 4. Original is 5. Original length is 5 long. Because it's given 5, isn't it? Forget about the 5 actually. No 5, cancel the 5. Meaning that this spring will extend by 4 cm. Whereas this spring P will extend 8. Where to get 8 length? You look at P, 10 gram extend 4. Now 20 gram must be double. Double of 4 become 8 long. So meaning that this one will extend 8. This one extend 4. So you put here, for A, 20 gram extend 4. For B, 20 gram extend 4. So the total stretch, you add up 4 plus 8. So it's 12. Okay, like that. Okay. This one extended 4. This one extended 8. So all together is 4 plus 8. So it's 12 cm. So the total stretch is 12 cm. Okay, now go to question B. Now you put both spring in parallel, but this is spring A. Can you all try first? Can you all try to get the answer? This spring will stretch or extend by how many cm? Try, I give you 1 minute. Okay, try to work out this one. Here only A, only no B. Only spring A, no spring B. Okay, try. Okay, I see someone got answer already. Juling say 5. Zhao Yi also say 5. And both of you give the same answer. Okay, let's see the answer. Is it 5? Yes, correct. 5. How to get 5 then? Okay, like this. Since this one both are A, right? Okay, they are in parallel. So 50 gram will share out. So this one support 25. This one support 25. So you do like this. 10 gram extended 2 is given. 10 is 2. 10 gram extended 2. 25 extended how much? 10 is 2. So 25 is how much? So you cross multiply. 10 plus y. This one multiply this equal to 25 times 2. So y is 5. Y is 5 means the stretch is 5 cm. Okay? Can understand? Evangeline, understand? Evangeline, do you understand? Jason, understand? Lau Guan Xuan, Jason, this one understand or not?
Understand.
Okay, good. Okay, now you have to try C. Look at section C. Try to answer C now. Okay, can understand. Now go to C now. Okay, so fast, you see. Juling says 16. Juling already got the answer. Any more? Any more got answer? Nitilan said 24. Nitilan 24. Juling says 16. I don't know which one is correct. Any more? Ryan said 20. Now three students give 3 different answers. Okay, one more. Chao Yi, Chong Chao Yi gave 16. Now 2 students give 16 already. Sing Yin also says 16. More students give 16 already. Any more? Any more student? Any more answer? I see many students give 16 now. Chai Ling also says 16. Yu Tong, no response. Yu Tong just sit down there, no response. And Yu Tong, why no answer? The answer is 16. Okay, come. You see how you get 16. So many of you give the correct answer. So here is 40 grams. So this one spring only, no sharing. So this spring support 40. 40. So it will extend by 8 block because for spring A, right, 10 is 2. So 40 must be 8. 40 means 4 times 2 times 4 become 8 block. Right? Here, because parallel, so you share out. 40 grams you put here, so this one only support 20, this one support 20. You take 20 only. So now you take P, 20. P, 10 grams is 4, 20 must be 8, correct not here? Because spring B, 10 grams 4. Now you put 20, so must be 8 block. So total strength is 8 plus 8, 16. Okay? Yeah. Okay, now take some time, copy down the answer and digest it, understand it, okay? All right, start from now. Ati, understand? Ati Subramaniam. Can hear me or not? Ati? Yes, can understand, Ati? Chan Yuan Yi, can understand? Chan Yuan Yi.
Yes, sir.
Okay. Jolin, what about you, Jolin? Jolin, can understand? Jolin Lim. Okay, Jolin say okay. Okay, come, we move on. Next one is elastic potential energy. What is elastic potential energy? Something new for you, know. What is elastic potential energy? Okay. Elastic potential means is an energy stored inside a spring when the spring is compressed or when the spring is stretched. Okay. You know one, you look at a spring, when you compress the spring, sure got energy one, because when you let go, you see the spring will eject, right? Same thing when you stretch the spring, you stretch, put it very long, you let go, and then you see the power, right? So meaning that the energy stored inside a spring, so it's called elastic potential energy, okay? So far, this is the second potential energy you learn, you know. Because in your syllabus, in lower form, you learn one potential energy, so we call it gravitational potential. Gravitational potential is a potential energy caused by the position of the object. The object is very high. For example, a coconut or a durian. The durian on the tree, there's energy stored inside because when the durian drop on your head, and you know what happened. There's a lot of energy, So that energy is called gravitational because of the high position. Now this is energy stored in a spring, so we call it elastic potential energy. Okay, now the formula. Elastic potential energy, EE. First one is half Fx, so memorize the formula. half times force times extension. X is extension. First formula, huh? Second formula is half kx squared. Okay, half kx, half times spring constant k times square of extension. And class, when you are using half fx or half kx squared, right? The x extension must change to meter. Cannot use cm. Extension in cm cannot use. The extension must change to meter. Okay. Half fx, half kx squared. Half kx squared, this formula you can only use when you know the spring constant. If the spring constant not provided, you cannot use this formula. This formula can only use when you know the spring constant. By the way, what is K? What is spring constant? Actually, spring constant is what? Remember or not? What is spring constant? Lao Guan Xuan. K spring constant is what actually? Guan Xuan. You see the formula, Hooke's law formula, F equal Kx. This is Hooke's law formula, correct not? And the K must be, you take the X over divide is force over X. So this is spring constant now, but how to put it in sentence? Spring constant is what? Force per unit extension. This is Jouling answer. Yes, Jouling, correct. Force per unit extension, spring constant, okay? And the third formula, to find the elastic potential energy, you find area under the graph. Find area under the graph, force over extension. When you have this graph, this is force. Force is here. This is extension, right? So you have a graph like that. So to find the energy, so you just find area under the graph. Find this area, okay? Area under the graph. Though only the graph of force against extension can use, area under the graph, okay? Okay, now 1 minute, memorize the 3 formula to find elastic potential energy. 1, 2, 3, got 3 formula. Come on. Someone playing the games. I can hear the sound. Okay, come, memorize the 3 formula. The one playing games, I know it's who, Bokman How, BMH. Are you playing games? Bok. Okay, time's up now. Yeah. Lim Jia An. Lim Jia An, come out, please. Lim Jia An, where are you? Lim Jia An.
Yes, sir.
Lim, can you tell me first formula to find elastic potential is what?
1/2 fx.
Yes. Second one?
1/2 kx squared.
Okay. Third?
Area under the graph f and x.
Okay. Remember that. Thank you very much. Okay. Now, use these 3 formula to find the answer for next question. Okay. Do it now. I want you to answer this question. Okay. All right. This one. Question number 2. Okay. Do now. Original length of spring is 12 cm. With the loads of 20 gram, the length of the spring is extended to 15. Extended to 15. What is the elastic potential energy stored in the spring? Okay. Answer this question now, everyone. Okay. Let's see the answer. Juling say answer 0.3. Juling, I'm not finished yet, because I asked you to find the elastic potential energy. Juling, not done yet. Any more answer from anyone? Calculate the elastic potential energy. Zhao Yi said 0.003. Brian answer 3. 3 not correct. 0.3 also not correct. 0.003 is correct. Zhao Yi, 0.003, what unit? The unit must be correct. No, what unit? Zhong Zhao Yi. Yes, Joe. Okay, well done, Zhao Yi. Now you check your answer. Okay. First, change the 20 gram to kilo, divide 1,000, you get 0.02 kilo. 1 kilo, 10 Newton, so you times Newton, you get 0.2 Newton. So the force is 0.2 Newton. Force must be Newton, to get Newton mean the gram change to kilogram times 10 Newton, you get 0.2 Newton. And the extension is 3 cm. From 12 go to 15, extended 3 cm. 3 cm cannot use. I told you must change to meter. Divide 100, you get 0.03 meter. And then finally put into this formula to find elastic potential. Half F is 0.2, extension is 0.03 meter. Half times 0.2 times 0.03, use a calculator, you get this answer. 0.003 joule. Energy is joule. Okay, copy down the answer now. Okay, those who finish, go answer the next question now. Go answer the next question. Next one also got someone give answer already. Shall we say 4? Sing in also say 4. 2 students give 4 already. What about others? Where is Chloe Chu? Chu not here today. I never see her now. Wu Ji Zhong also say 4. Yes, correct. The answer is 4 lah, huh? Okay, come check. Now, find area under the graph. Here is 0.4. The base is 0.4. The height is 20. So half times base times height. Half times 0.4 times 20. So you get 4 lah. 4 joule. The unit for energy is joule. Okay. So this one, okay, finish. Move to the next one. Answer next one. Juling, where's your good friend? These are 2 here.
She celebrated New Year earlier, Raja.
Yeah, so fast. So fast to celebrate already. Not even the New Year. If yet she's celebrating already. Juling. She balik kampung.
She tell me one, I don't know.
She balik kampung meh?
No lah, how to balik?
Maybe in Malacca can come balik ma.
I think she lazy lah, Raja.
Yeah lah, I think so lah. She's very lazy, oh.
Yeah.
This one also got people give answer already. Brian said 0.16. Okay, come, let's see the answer. Okay, let's see the question said. I don't have answer here, no. Figure show a ball 10 gram. 10 gram change to kilo is 0.01 kilo lah. Push against the end of the spring. You see the diagram lah. The ball push against the spring, and then suddenly you let go. The original length of the spring is 14 cm. And each spring constant is 200. K given already. The spring constant given is 200 Newton per meter. Okay, now, first answer, Brian, you are right, 0.16. So to find the elastic potential, half kx squared. K spring constant is 200 given. X extension 4 cm, you see here. From 14, you push, become 10, so shorten by 4. So extension or compression is the same. 4 cm change to meter, 0.04. Square, half kx squared. Use a calculator, you get 0.16 joule. Okay. Okay, this one done. Now go to B now. Anyone got the answer for B? The minimum velocity reached by the ball after compression force is removed. When you remove your hand, definitely this spring will eject, push the ball to fly. So it's something like a bullet, you know. Okay, actually, this is a mechanism for gun. How the gun shoot out the bullet is using spring one, you know. When you trigger the gun, the spring will push the bullet to fly, okay, to shoot out. So you can imagine in the gun, how powerful the spring, okay. So now, when this one is moving, so it asks you to find what is the maximum speed, velocity of the spring of this ball can fly. What is the maximum velocity can reach by the ball? Another answer come out, I see. 16. Brian just now said 0.16. Now he said 16. No, still not correct. Anyone? Any more? To answer this question now, okay, tips, I give you tips. You have to use a principle of conservation of energy. Okay, now you see the question now. When you compress the spring, so you have elastic potential energy. Hui San got the answer. Yes, Hui San, you are very, very good. Hui San, thank you. Hui San got the answer already. You must start from elastic potential energy. Store in the spring, when you release it, so this elastic potential will change to kinetic because it makes the ball moving. So it's kinetic energy, half mv squared. So elastic potential change to kinetic energy because when the ball is moving, so it becomes kinetic energy. So kinetic energy formula is half mv squared. This one you learn in Form 4, right? Kinetic energy half mv squared. So this potential pick here 0.16. And 2 times here you get 0.32. Mass is 0.01. Just now we calculated already 0.01 kilogram. Find the v squared, 5v lah. Bring over, you get square root 32. So 5.67 meter per second. Okay, this one using the principle of conservation of energy. So elastic potential energy will change to kinetic energy when the ball is moving. So the formula for elastic potential is half mv squared. The mass must be in kilogram, 0.01 kilo. So you find the v square root in lah, okay? Understand it, Copy and understand it, everyone. Okay. And now we go to answer the objective question. Okay, go one by one. Question number 1. Yuan Yi, what answer? The property of elasticity is caused by existence of what? Yuan Yi.
C.
C. Yes, correct. C. This is because of force of repulsion and the force of attraction. Two forces. Okay, number 2. K is a spring constant. What is the units of spring constant K? What is the unit? What is the units of spring constant? Kaho. Kaho?
Yes.
Kaho, what is the answer for question number 2? What is the unit for spring constant K?
A.
Yes, correct. Zhao Yi also say A, correct. Hooke's law, F equal to Kx. So K is F over X. So force is Newton. X is meter, extension in meter. So Newton per meter. Okay. And number 3. So spring constant K increases when, okay. Spring constant K increases means the spring become harder, become stiffer. The spring become very hard, very stiff. So Which one can make the spring constant increases, become the spring, make the spring harder lah? Netherlands. Number 3, Netherlands, are you there? Netherlands, ah?
Yes, sir.
Number 3, can
C.
you tell me? Yes, the answer C. Okay, because the diameter of the spring wire increases, mean you make the wire thicker. When the wire thicker, mean it become harder, become stiffer, right? So the spring constant will become bigger lah. Yeah. Okay. Question number 4. Do the calculation now, okay, everyone. What is the values of P? Okay, do everyone try. Original is 18 cm. When you put P, it becomes 10 cm. When you put 10 kg, it becomes 8. So now they ask you, what is P? Anyone got the answer? Yuling got answer or not? Chao Yi got answer or not? Yi Ping, any idea? Yi Ping? Okay, how he? Chao Yi say A, and then Bernard say C. Lim Sing Yin also says C. Yes, the answer is C. Okay, come. How to get C? Now you check your answer. This is how you get the C. 10 kg, you put 10 kg now, is shortened by 10 cm because from 18, it becomes 8, means shortened by 10 cm now. So 10 kg shortened by 10 cm. P shortened by 8, from 18 drop to 8. Drop to 8 mean drop to 10 mean 8 cm lah. 10 kg is 10. How P is 8. So cross multiply. E times 10 equal to 10 times 8. So you get P 8 kg. So answer C. The next question. What is the values of M? Okay. Try number 5. Bernard also got the answer. But Bernard is very good. No, this Bernard, this boy. Any other answer besides Bernard? Yes, Bernard. Well done. Your answer is correct. Okay. Let's see another student's answer. Yi Ping also said P. Yes, correct, Yi Ping. Okay, both students keep the correct. Now you check. It's like that. Okay, now 60 gram, the spring extended 5 cm. Now you see here, from 10 go to 15, extended 5 cm. Now, when you put 60 gram, extended 5. So you put here 60, extended 5. Now you find the whole thing here. From 10 go to 30 mean extended 20. 20, right? So how many gram extend 20? So you find the x lah. Cross multiply x times 5 equal to 20 times 60. So x you get 240. 240 is the total here. You have to minus the 60 to get the m. Okay, 240 minus 60, so you get 1x0 lah. You want to find the m. Our answer here 240 is the whole thing. Yeah, understand it, Yu Tong, do you understand? Wu Yu Tong.
Yes, sir.
Good lah, can understand, it's good. Ka Ho, understand?
Yes, sir.
Okay, good. Lee Jia Singh, can you understand that? Lee Jia Singh?
Yes, sir.
Okay, good. Sakti Asa, why is 20 cm? Okay, very good question, Sakti. Now you see here, Sakti, I'm explaining here. Initially, the reading here was 10. Now you put here, you want to find here. So the extension must be from 10 go to 30. From 10 to 30 cm means extended 20 cm. 30 minus 10, you get 20. Sakti, understand? From 10, you go to 30. That means extended by 20. Okay? Okay, understand already, Sakti? Okay. So now the answer is 1x0. Okay, move to the next question now. Number 6. Is that finished, everyone? Now number 6. Number 6, no calculation. Just give your opinion on it. There are 3 spin PQR. Which comparison is correct about the extension? Which one extend the most? Which one extend the least? Bernard again. Lee Jia Singh also give correct already. Yeah, Bernard, Jia Singh, both of you correct. Nitilan, please check your answer. Nitilan. Nitilan, check one more time. Which one extended the most? Because he said comparison correct about the extension. Very obvious. This spring will extend the most, isn't it? When you connect them in series, this one maximum, the extension is the most extended. This one second. This one extended the least. So which answer is correct? A, B, C. Which one is correct? A, B, C, D. 2 students keep correct answer already, but I don't want you to know well. Any more answer? Okay, one more, you see. Sing Yin says C. Nitilan also C. Not correct, no. Not C. Which one is the answer? Now correct. Juling, Sakti, Sing Yin, correct. 3 of you give the correct answer. Yiping also give the correct answer. Yes, well done. Correct. Now everyone keep correct already. Wow. Wu Chi Chong, you don't scare me, you know. Wu Chi Chong. Wu Chi Chong, you don't scare me, you know. So the answer is A. Let's see Wu Chi Chong. Yes, correct. Wu Chi Chong, A, correct. P, actually you see the bullet R is bigger than Q, the extension. R bigger than Q, Q bigger than P, correct? Not the bullet you see. So A. This one extended the most, this one number 2. This one extended the least. So P, you see like this, R bigger than Q, Q bigger than P, okay? Now 1U, can 1U come in. Then later on, this Chloe Chu will come in. Okay, now number 7. I'll give you a little bit tips. You follow this one, you do, okay? Follow the tips and do. Bernard already got the answer. I'm very fast. Bernard, how, Lee Jia Singh, but both of them the answer different. I don't want to say who is correct, who is wrong. Jason and Brian also give another answer. B3 fella give 3 different answers. 3, right? And now got 2 correct already. Hey, change again. 3 students give answer. 2 correct. One not correct. Any more? Brian. Jaan. Jaan, Sakti. Not correct. No, the answer not correct. Sakti, Jaan, not correct. Try again. Okay lah, come. This one let me explain lah. Singin also not correct. Okay, now come, let me explain. Come. Figure show two spring K. Now got two different spring, Original length 5. Connected to 400 gram. Okay, now for K, this spring, extend 2 cm and hung with 200. Okay, right here, 200 extend 2. Now you put 400. This one also support 400, right? 400 must be 4. Whereas for L, extend 3 when hung with 100. 100 is 3. Now 400. When you put 400 like this, this one support 400. This one also support 400 one, no sharing one. Series. So for L, 100 gram, 3 cm. 400 must be 4 times. 4 times 3, 12. So now, the question asks the length of AP. The length, you must add the original length. So original length, don't forget the 5. Sakti. Okay, Sakti, you listen to my explanation now. Okay, now you see the answer. The length of AP must also consider the original length 5 cm. So this is 5 plus 4. 5 cm plus extended 4 cm, 5 plus 4 lah. This one is also 5 cm plus 12, extended 12. So 5 plus 12. So you add up, you get 26. There are few of them got the correct answer, 26 cm. So 5 plus 4 is here, original length plus the extension 4. Here, original 5 plus extension 12. So all together 26. กันวันยู你跑去哪里是过年是吗 Okay, next. 睡觉这样早睡觉了咩？干完又Okay, number 8. Okay, come on. Let's see what answer number 8. You follow the tips I give here, right? You follow, you can find the answer. What is value L? So fast, all this follow give answer already. Bernard. Bernard, this time your answer not correct. Bernard, not correct. Bernard. Brian, very good. Okay. Brian, very good. Correct. Okay, come see the answer. The original length of the spring is 10 cm. Compressed to 8 by load 20 Newton. When you put 20 Newton, it from 10 go to 8, shortened by 2 cm. So you write there 20 Newton shortened by 2 cm. 10 go to 8, shortened by 2. Now you put like this, 60 Newton. 60 here got 2. So this one take 30. This one take 30. Okay, this one take 20, 20, 20. So you calculate like this. If 30, if 20 is 2, 30 must be 3. So meaning that here shortened by 3. So you take 10 minus 3. That's 7. Original length 10 cm, shortened by 3. So you minus 3. Here shortened by 2. Because 20 gram, 20 Newton definitely is 2 cm. Now you see here. So this one shortened by 2, so it's minus 2. So now the total length is 7 plus 8, so it's 15 cm. Okay. Bernard, I forgot to add the original length. But your answer is still correct. Oh, sorry, Bernard. Okay, Bernard. Now you understand already, Bernard. Hey, the rest of you understand or not? So far here, only a few always responding one. Bernard, Brian, Chow Yi, Sing Yin, Chiu Ling, only these few. Sakti also give answer lah. The rest must also give response lah. Don't just say behind. Okay, come number 9. Use this formula to find. Compressed with a force of 300 Newton. Compression of spring 0.05 meter. So very straightforward. What is the elastic potential? Half Fx. I believe someone give answer already very fast. 3 fellow give answer. Dylan say, where's the answer already? Dylan? A. Zhao Yi also say A. Sing Yin also A. Bernard also A. Yes. Jia Xing A. But so many A. Jian An also A. Jia An. Yes, correct lah. All of you give the correct answer. Well done, everyone. A. Half Fx. Just multiply, you get 7.5 joule. Okay, Okay, number 10. Number 10. Figure shows the arrangement of apparatus to investigate the relationship between the extension X and the weight W. This is a weight, this is the extension. Okay. SI unit for weight is Newton. This one you know one, for weight is Newton. The SI unit for weight is Newton, not kilogram. Kilogram is mass, not weight. Okay, Next, name the law. What is the name of the law? What is the name of the law regarding the spring one? What is the name? Hooke's law lah. Direct, see the answer. Hooke's law. And state the relation between the X and the W from the graph you see, right? Directly proportional lah. It's a straight line passed through the origin. So the relationship is directly proportional. And state the physical quantity can be represented by the area under the graph. You know already, right? Area under the graph is energy, elastic potential energy. You just learn it. Elastic potential energy is the area under the graph. Force against the X, but here weight and force same one. Weight in Newton, force also in Newton. Okay, last question. This one I explain, you all listen. Figure show a graph extension against a force. And here is extension. Here is force. This is not Hooke's law graph. Hooke's law is this one. Force here. Extension is here one. Hooke's law. Okay. F equal to Kx is here, When you find the gradient is F divided by X. Right? X, F here, X is here. Gradient, F divided by X. And the gradient is same as a spring constant K. Spring constant K, F over X, same as a gradient. This way you can say the spring constant is equal to the gradient. That is for Hooke's law. Right? And now this graph is terbalik, Okay, for Hooke's law, we say when the gradient is big, spring constant is also big. Meaning that when the spring constant is big, the spring is very stiff, very hard. So by looking at the graph, the gradient peak means the spring is stiff. You learned before one, okay? Now you see here, I show you back. The other day you learned this one. Okay, now this one. This one we say that this one is stiff. You see the spring is stiff. Okay. Because gradient big, so this one stiff. This one gradient small, so it's soft. When you F is here, X is here, we see like this one stiff, this one soft. Now go back this question. This one is the terbalik. No, you see, different from the graph I showed you just now. This is X, this is F terbalik. So now how? In a case like that, how to see? Okay, we answer the question straight away. Okay. First one, relationship. Strict line, so it's directly proportional. X is directly proportional to F. You read X, Y first. X directly proportional to force. Law, Hooke's law. Okay, no other law. Sure, it's Hooke's law. Next, what is a physical quantity represented by the gradient of the graph? This graph. If this graph, gradient, I told you, gradient is a spring constant. What about this one? When you terbalik, here is Fx, here is X, F terbalik. So the gradient is become 1 over K because gradient is F over X. Now you terbalik here, the gradient is X over F, terbalik. So X divided by F, you terbalik this one, so K also terbalik, so it becomes 1 over K. So the physical quantity represented by gradient of this graph is not spring constant, it's 1 over spring constant. Okay? 1 over spring constant. 1 over K. And the last, which spring most suitable to measure peak force? Peak force means very strong one. The spring, which one is stiffer? Between A and B, which one is stiffer? Come on, give response. Which spring is stiffer, A or B? Yeah, very smart, all this fella. Yes, correct. B. Because the graph terbalik already, terbalik from the Hooke's law, right? So small gradient actually should be stiffer. So this one stiffer, terbalik. This one soft. Yes, the answer B lah. And then the reason it is stiffer. And finally, before you go for Chinese New Year, 2 factor why the extensions of A different from B. Why this extension and this extension are different one? Yeah, by the way, I want to tell you one more way to see. You see which one hard, which one soft, you see like this. For spring B, right, to extend force cm, you need 10 Newton force. For spring B, to extend same force cm, you only need 5. So which one is hard, which one soft, you can very easy to see. This one harder lah, because to extend force cm, you need more force of 10 Newton. You have to pull harder. So this spring is hard lah, stiff. This one to extend for, you only need 5, very small force, 5 Newton can already. So this is stiff, this is soft. Okay, now 2 factors make the extension different. What are the 2 factors make them different? You have learned so many, diameter lah, types of material lah, all these different, correct? Not? So the answer, check. Types of material spring may be different. That's why the extension different now. Another one is the diameter of the spring wire may different. When the diameter of spring wire different, of course, the elasticity different, isn't it? Okay. So, okay, copy down all these answers. So tonight, I stop here. This week I let you go earlier. I also need to go earlier because busy, very busy this week. Okay, Chinese New Year. Okay, finish already, everyone. Okay, I stop here. Okay, now come back here. Arti, anything to ask or not? Arti Subramaniam, any question here? Ram, anything to ask? Simeon, Mr. Simeon, anything to ask?
No, sir.
No, sir. Simeon very shy, this boy. Wang Zijian, anything to ask?
No.
No. Sure, 2 times and no. Sakti, any question to ask? No question. Okay, if no question, I wish every one of you here, those who are celebrating Chinese New Year, a very happy Chinese New Year. 新年快乐，万事如意啊 For those who are celebrating, enjoy your Chinese New Year, but be careful always follow SOP. Okay, and for those who are not celebrating, happy holiday. Nitilan, Arti, Sakti, Simeon, happy holiday. So enjoy your holiday Okay, Kong Fan Sin, anything to ask, Kong Fan Sin?
No, sir.
No, sir. Okay. So I see you next week. Okay. Happy Chinese New Year. Happy holiday. Okay. Bye-bye. Okay, bye-bye.
Thank you, sir.
Thank you, sir.
Okay. Bye-bye.
Thank
Bye-bye,
you, sir.
everyone.
Thank
Thank
you,
you,
sir.
sir.
Okay. Bye-bye. Yes. Bye-bye.
Thank you,
Bye-bye.
sir.
Thank you.
Yes. Bye. Bye. Bye-bye.